In this video, we're going to take a look at simplifying radical expressions. Let's take a look at the square root of 4. Many of you know that the square root of 4 equals 2. Because 4 is a perfect square, it's pretty straightforward. Suppose we have a radical that contains a number which is not a perfect square. We look to see whether it can be simplified. What we're looking for is the largest perfect square factor contained in the radicand, which is the part inside our radical. One way to find it is to do a prime factorization on the number inside the radical. In other words, let's take this number 90 and break it down into a product of primes. One prime number that I know divides into 90 is 5. I know that 5 divides into 90 18 times. Now I look at 18. I know that 2 is a prime number which divides into 18. It divides into 18 9 times. And I know that 9 is a product of the prime numbers 3 times 3. Since I can't break 90 down any further, I have my prime factorization. I can rewrite this as 2 times 3 times 3 times 5. Now since I'm taking the square root of 90, any pairs that I have inside the radical represent a perfect square. Here I have 3 times 3, which is 9, a perfect square. I can take the square root of this and write it in front of the radical. So now I have 3 times the square root of 2 times 5, and I can write this as 3 square root of 10. So now we have simplified the square root of 90. Let's take a look at an example that's a little bit more complicated. Suppose I want to simplify the radical expression, the cube root of 125a to the 6th b squared. I know that the cube root of 125 is 5, because 5 times 5 times 5 equals 125. If I didn't know this, then I would start by doing a prime factorization on 125. But since I know the cube root, I'll write it. I'll get this set up here. The cube root of a to the 6th is a squared. And I know this because I can divide my root 3 into my exponent 6, and it divides evenly 2 times. With b squared, cube root 3 divides into exponent 2. It's not evenly dividing into it, so I need to leave b squared in the radicand. So I'm left with, let's rewrite this, 5a squared cube root of b squared. And so now our radical expression is completely simplified. Let's take a look at one more example. Suppose I have the 5th root of negative 32 x to the 5th y to the 6th. I know that the 5th root of negative 32 is a real number because odd roots of negative numbers are also real numbers. If that were an even root with a negative number inside the radical, then that would not be a real number. But it's a real number. The 5th root of negative 32 is negative 2. And that's something that if you didn't know, you could do a prime factorization to determine. The 5th root of x to the 5th is x to the 1st. And I know this because my root 5 divides into the exponent 5 one time. And then for y to the 6th, I see that 5 divides into 6 one time, so I can take out y. And I'm left with the 5th root of y. because 5 divides into 6 one time with 1 left over. That's it for our example. I hope that you have found it helpful. See you next time.